Hello! Yes! And welcome to our Objective 1.10 notes, the final notes for Unit 1. That our final objective, Objective 10, says I can evaluate and graph a piecewise function. Now, a piecewise function is a function that is composed of multiple equations, and each equation is given a subdomain. So let's talk about how these look here. So looking at our example of a piecewise function, looking at letter A here, f of x equals negative 2x plus 1 when x is less than 0. So if my input is less than 0, I use this equation. 3x minus 5 if x is greater than or equal to 0. So if my input is greater than or equal to 0, I use this equation. Same idea here with letter B. X plus 4 if x is less than 2. It is 6 if x is between negative 2 and 1. And it's negative x minus 6 if x is greater than or equal to 1. And then looking at letter C here, h of x, absolute value of x minus 5 when x is less than 4. Square root of x minus 4 when x is greater than or equal to 4. So with that being said, evaluating these is very straightforward. Let's look at letter A, f of negative 3. So this is telling me I'm going to use function f right here, and I want to input negative 3. So which equation will I use? To determine that, I look here. My input, negative 3, is less than 0. So that means I'm going to use negative 2x plus 1. So I would say f of negative 3 equals negative 2 times negative 3 plus 1, which is negative 2 times negative 3 is 6 plus 1, and I find that f of negative 3 is 7. So this is a good review for one of our early objectives where we were evaluating functions. Now we're just doing that again with piecewise. So let's look at letter B here, h of 4. So looking at h, that's this one here. My input is 4. So, okay, my first equation is when x is less than 4. My second is when x is greater than or equal to 4. So that's what I qualify for. So that will be the equation that I use, the square root of x minus 4. So I would say the square root of 4 minus 4. And 4 minus 4 is just 0. So h of 4 equals 0. There we go. Now let's look at g of 5 here. Letter C, g of 5. For here, I would say, okay, which equation? 5 is greater than or equal to 1, so I will use negative x minus 6. So that means g of 5 will equal the opposite of 5 minus 6. Negative 5 minus 6 is negative 11. So that then is g of 5. g of 5 equals negative 11. And that's evaluating piecewise functions. We're also going to talk about graphing them. Now, graphing them is a bit more intense. When graphing piecewise, we're going to use these following steps. One, we're going to make notes of the subdomains. And I'm going to do that with dashed lines. There are other ways to do it, but feel free to do it like me. Or you can draw lines above the coordinate plane, whatever works best for you. We'll make a table of points for each function with the appropriate inputs. We'll graph each equation, and then we'll add open or closed circles. So remember, open circle will be used when the function, when subdomain has domain, spelling is hard, don't pretend there's none either. When the subdomain has strictly less than or strictly greater than inequality signs. We'll use closed circles when the subdomain has the greater than or equal to or less than or equal to signs. The signs like that. That will be when we use our closed circles. Okay, so let's try one together. So looking at letter A, negative 2x plus 1 when x is less than 0, 3x minus 5 when x is greater than or equal to 0. So these are both linear. I'm going to start by putting that dashed line where x equals 0. Okay, that's one of the value. That's the value of my subdomain. That's where it splits. So on the left half of my coordinate plane, I will have one graph. On the right half, I will have another. So let's do negative 2x plus 1. I'm going to make an xy table. I always am going to start with my subdomain value, so that'd be 0, and then I want values less than 0, so I'll go down from there. Negative 1, negative 2, negative 3. Now when I plug those values in, negative 2x, so negative 2 times 0 plus 1 is 1. Negative 2 times negative 1 is 2 plus 1, so that's 3. Negative 2 times negative 2 is 4 plus 1 is 5. 1, 3, 5, 7. We can see that pattern starting to develop there. Okay, now let's do the other one. 3x minus 5 when x is greater than or equal to 0. So I will start with 0, and I'll go up from there. 2, 3. So that gives me -5. 3 times 1 is 3, minus 5 is -2. 3 times 2 is 6, minus 5 is 1. I can see that pattern start to develop from there as well. Okay, so now I'm going to graph both of these points. Let's start with the -2x plus 1. When x is 0, y is 1. When x is -1, y is 3. When x is -2, y is 5. When x is -3, y is 7. Very good. 3x minus 5. When x is 0, y is -5. When x is 1, y is -2. 2 is 1. 3 is 4. And we can go ahead and continue. We see those visual representations now. We can see the slope of these lines. All right, so I've plotted the points. The final step is to determine which of the points that are on this dashed line, which of the points on this dashed line has the open circle and which has the closed circle. Now, it's important we do that because as I've drawn it right now with 2 closed circles, this wouldn't pass the vertical line test, right? I'd have 2 outputs for 1 input. That's not the case. So -2x plus 1 is when x is strictly less than 0. So that means this value here will have the open circle. This value here will have the closed circle because that is when x is greater than or equal to 0. So that's when it's greater than or equal to. So I'll have a closed circle here. I will have an open circle at that 1 value. And then I can connect my lines, connect my dots, show those continuing that way, show those continuing that way. There we go. And now I have graphed this piecewise function. All right, let's try one more together. All right, looking at letter B, I have x plus 4 when x is less than -2, 6 when it's between -2 and 1, -x minus 6 when it's greater than 1. So I'm going to start with my subdomains. I have a subdomain split at -2, so I'm going to put a dashed line there, and a subdomain split at 1, I'm going to put a dashed line there. Now let's make some tables of points. So we'll have x plus 4 when x is less than -2. So I'll start with -2 and I'll go down from there. -3, -4, -5. So x plus 4, -2 plus 4 would be 2. -3 plus 4 would be 1. -4 plus 4 would be 0. 5, -1. There we go. We can see that pattern. Now 6 is an interesting one because that tells me my output is always 6. Notice my domain restrictions are between -2 and 1, so I can just go ahead and list all of those. And for all of these, the value will be 6. And then we have -x minus 6. -x minus 6 when x is greater than or equal to 1. So I'll start with 1, and I'll go up from there. So -1 minus 6 would be -7. -2 minus 6 is -8. -3 minus 6 is -9. -4 minus 6, -10. There we go. All right, so let's plot these points. So I have -2, 2, -3, 1, -4 is 0, and I can go ahead and continue this all the way out here. There we go. All right, I have -2 is at 6, -1 is at 6, 6, and 6. Excellent. And then I have 1 at -7, 2 at -8, 3 at -9, 4 at -10, and those we can continue on out. Okay, so notice here, I went ahead and put this closed circle on this one because this is greater than or equal to, which means I'm going to have an open circle here, which makes sense since this is strictly less than 1. However, at -2, I will have a closed circle because it's greater than or equal to, or sorry, -2 is less than or equal to x. X is greater than or equal to 2. And since x is strictly less than -2 for that x plus 4 function, that will be an open circle. And I can go from there. All right. There we go. Hopefully you're feeling good about these. If you want a little more exposure to this idea, go ahead and check out the sample problems video. Otherwise, go ahead and get started on those practice problems. This is Mr. Carter signing off with our final notes for Objective 1. For Unit 1, excuse me. Unit 1. I do not want to start back over with Objective 1. That sounds like a disaster. Let's hit this sign off again. This is Mr. Carter signing off with our final notes from Unit 1. I'll see you next time.